Sure.
Yeah, for moment fixed and moment BA, you're gonna have a fixed and a pin. So you're gonna use this one, 3EI delta over L squared. So you're gonna have this 3E32 delta over 16 squared. And for fixed and moment CF, fixed and a fixed. So you're gonna have to use this one, 6EI delta over L squared. And for fixed and moment DE is a fixed and a pin. So you're gonna use 3EI delta divided by L squared. And you get these numbers, and you have to put it in because the fixed and moment in this case, since you have a delta, so you don't know what is the volume, you can't just find the actual numbers. So what you're gonna do, you just pick one of them, anyone, to set it equal to 100. So anyone, it's not gonna affect your numbers and results. So just pick anyone. You can pick anyone. Like for example, I pick fixed and moment BA is equal to 100. For example, I pick this as 100. But first of all, I'm gonna pick this number as 100. So I have to find the ratio for this one and this one, so I can find the real number for this two. If this is 100, just find the ratio. Where should I start? I want to erase that. So for ratio,
Let's look at the bottom.
you want to find a ratio for this one and this one. So you're going to take, I'm going to let this equal to 100, so I'm going to pick this one. So 3E32 delta over 16 squared over this one and this one. So let's do this one first. 6E 40 delta over 20 squared. You take this divided by that, because you know delta cancel, E and E cancel. So you just take 3 times 22 divided by 16 squared, get the number, and then divided by 6 times 40 divided by 20 squared. So you're going to have the ratio, which is 0.625. And this ratio is for fixed and moment CF. You got this ratio, but you also have to find a ratio for this one. So you do it again. You're going to take this divided by that. So the top part is not going to change. All it's changed is the bottom part. So you have 3EI times 24 divided by 12 squared. So you're going to have 3EI times 24 divided by 12 squared. You do that, you're going to get a new ratio, which is 0.75. So we set fixed end moment BA equal to 100. And the ratio for this one is for this, for fixed end moment DE. You want to find the real number for fixed moment DE, you take 100 divided by your ratio. You're going to have that 133.35.
Right, FEMDE.
FEMDE. And like I said, no, let's do not finish another one too. And for fixed end moment CF, no, that one is CF. For CF, wait, this is DE, it's for CF. You're going to take 100 divided by the ratio for the CF, which is 0.625, and you're gonna have 160. This is just a value. You have to know, you have because determine is this positive or negative. How are you gonna do that? This is gonna sway this way. That's why you need some moment acting this way to bring this back to the original. Sending here. And this moment is counterclockwise, so it's negative. So everything is going to be negative. So negative, negative, and negative. So after you find the fixed end moment, you have to just put it back into the table. Send table. The K is not going to change. Distribution factor is not going to change. All you change is just the FEM, so you have to change the FEM. You erase everything.
So counterclockwise moment is negative?
Yeah, counterclockwise is negative. Clockwise is positive. So in this case, counterclockwise. If you need help, you just bring your watch to the class during the test. That's what Maluf said. So for this one, for BA, you're going to have negative 100, because we set this as 100. And for CF, you're going to have negative 160, and for, what else? DE, you're going to have negative 133.35. And you know, like I said before, fixed end moment, fix and fix. So CF is equal to FC. So if CF is equal to negative 160, FC is also equal to negative 160. So you're going to have negative 160 FC. FC, CF, same thing. So you're going to erase everything. Doing the arrow. I think the arrow is going to change. Yeah, erase the arrow because that will change. Alright. Same thing. You have to do it 3 times, and after the number 3 carry over moment, you have to do one more time the distributed moment, and you just sum them. So for this one, for joint B, you add this, and you then times the factors. So this time, this negative times this number become positive. So you're gonna have 60, 40. This one you have to add this, and this. So you're gonna have negative negative plus this number become positive. So you're gonna have.
It's the same thing as you did before, right?
Yeah.
Okay, just write down all the numbers.
Okay. Yeah. I'm just gonna write down the numbers. But this time it's going to be a little bit different because you see the columns. Everything's here. All the numbers is in the column. So when you do the carry over, CB, BC, you do this one. So it's 20 and 20. CF, you do the same thing. You pick the CF, this number, to this one, FC, so half. And this one, you're going to have CD, DC, cause 20 and, wait, yeah. So you have 26.67. So you're going to have 20, nothing here. and then you just keep going. And you know what? Don't waste your time. This is what you should get. You'll see if you can see the numbers. I mean, you should get the numbers. It's example, like class example.
Alright, move it down, down. Move it towards the camera. Toward, up, down, down, down. That's it, hold it there. Okay, good.
Okay. You're gonna have the sum, the force, which is negative 491. I mean, you have the numbers, so for that. So what are you gonna do next?
Just write down the sum,
Then you know what? I'm gonna make that table. So at the end, you're gonna have this table. You're gonna have moment B8, BC, CB, CF, CD, DC, DE, FC, and in the first table, we got our result to be negative 104.06. 137.25, negative 94.5, negative 42.75, negative 14.06, 14.06. Wait, I missed one number. Wait, B8, BC, CB, CF, CD, DC, DE, FC. Wait, I missed one numbers. 104, negative 104.06. And for the table we just did, the one with the reaction, we have and for the so you're gonna have two more things. You're gonna have two more things. This one is going to be your correction factors. And the final moment. To find the correction factor, you have to do this. For this number, for the first table, the number with the distributed load, you're going to do this. you have 1 span, 2 span, 3 span, which is going to have the delta. So you're going to put this 3 span. And for the moment at B8, you have positive 104.06, which is clockwise, turning this way. 104.06. And for BC, no, not BC, CF. CF is negative, so it's counterclockwise. Turning this way. 4.5. And for DE, 14.06 clockwise. And you want to find the shear in the x-axis. And this one you didn't have any point load in between. If you see any point load in between, you have to put it back. But in this case, there's no point load. So you don't have to put anything. No point load, no point load, no loading on this bands. So it's fine, it's good. This one is 16 inch or feet, 20 feet, 12 feet. So you want to find this reaction. So you take the moment, you sum up the moment at this point, you're going to have, you should know how to do it. Sum up the moment at this point, so you're going to have, turning this way is positive, so you're going to have negative 104.06 plus V1, V2, V3. V2 or V1 times 16, and then you find this V. So V1 is equal to 6.5, V2 is 46.9, 1.17. So you add them. So you're gonna have, because R1 is going that way. So you're gonna have, you're gonna have R1 is going that way. So you're gonna have R1, the sum in the x-axis equal to 0, and it's equal to R1 plus before you have a 20 kip here. So we're gonna have R1 plus 20, because 20 also going that way, plus 6.5, plus 46.9, plus 1.17. And R1 is equal to positive. So you're going to have 20.6. And for this moment, this moment you do the same thing. 1, 2, 3 span. So for BA negative, so you're going to have counterclockwise. 49.1. CF, you're going to have negative, so also counterclockwise. And for the last one, DE, counterclockwise, 62.44. And you want to find this, wait. When you remove this, you're going to have R2 going back this way. So you're going to have plus this, plus that. This way. You're going to have this one. You find by V1, V2, V3, and this one is same thing. 16, 20, 12. So you sum up the moment at this point, you can find this. You find sum up the moment at this point, you can find this. You sum up the moment at this point, you can find this. So it's going to be 3.07, 129.67, 5.2. and you sum up the moment, you're gonna have, oh yeah, this is R1, the original one is acting this way, and when you remove the that thing is gonna have something like R2 going back this way. So you're gonna have sum the moment in the x-axis equal to 0, so you're gonna have all forces going this way. Share, share, and share, and that R2 is also going that way, so you're gonna have negative R2 minus 3.07 minus 129.67 minus 5.2. So you're gonna have R2 is gonna be 19.77. So for R1 plus R2 times X is equal to factor? No, it's not like that. Things like R1. Then did I copy it down?
Pause.
Yeah, yeah. Awesome.
Pause.